In this video, I'm going to demonstrate installation of the FRIGATE plugin for Magic Draw and FRIGATE sensor coverage analysis. I have already installed the prerequisite tools to run FRIGATE and Magic Draw on Windows. Those are the Windows subsystem for Linux and the binaries kind2 and z3. Windows subsystem for Linux is available for free from Microsoft, and kind2 and z3 have freely available binaries. You can check that those are installed by shift right-clicking on a directory, clicking Open Linux Shell here, and I can check that they're installed by either just trying to run them or by typing which. So I have both of these installed in the user bin directory of the Windows Linux subsystem. Now I'm going to switch to Magic Draw. I'm going to go to Help and Resource Plugin Manager. Go to Import and then navigate to the FRIGATE release 0.3.0. Once I'm in the 0.3.0 directory, I'm going to choose the FRIGATE Magic Draw 0.3.0 zip file and hit Open. That installs successfully, and then I will restart Magic Draw. I can confirm that FRIGATE is installed by going to Help, Resource Plugin Manager, and if I scroll down, oops, too far. If I scroll down, I can see that FRIGATE is in the installed list. I can also see in the custom diagram dialog, if I go down to my SysML diagram types, I now have a diagram called SysML goal function tree. Now I'm going to open up some examples that come with FRIGATE. So I'm going to navigate again to the FRIGATE release directory. Inside the FRIGATE release, there's a directory called Models and a directory called Magic Draw. I'm going to open up the sensor coverage examples MD-zip file. The sensor coverage examples model includes a variety of FRIGATE packages. Each of these packages has this 3 black rectangle goal function tree icon. Each of these is an example of sensor coverage analysis. We can look at one of these by navigating to one of the diagrams inside one of these packages. I'm going to start with a simple case of a missing sensor. When I open this diagram, it brings up the goal function tree palette, which consists of the different types of goals we can reason about with a goal function tree, different types of goal combination operators, sensors, state constraints, and some additional optional features we're not going to talk about in this video. In this example, we have a single goal called temperature maintenance. The constraints of that goal are defined by temperature bounds, which says temperature must be between 10 and 100. I can right-click on this maintenance goal, go to FRIGATE, sensor coverage, check sufficiency. FRIGATE runs, and it tells me my sufficiency check failed. If I hover over it, it says the temperature of 0 is an example for which this goal can fail, but no sensor reports a failure. This is pretty obvious because there is no sensor defined, so there's of course no way a sensor could detect this problem. Let's go to another example and see one where we do have a sensor. In this example, we have the same goal and the same state constraint, but now I've defined a sensor that says if this state constraint is exceeded, this sensor is going to report a problem. I'm going to go to FRIGATE, sensor coverage, check sufficiency. and we are now passing our sufficiency check. Let's look at a little more complicated example. Let's look at a situation where the sensor's constraint is different from the goal. In this case, I have the same temperature bound constraint, 10 to 100, but my sensor is checking between 10 and 20. Frigate says, yep, that's fine, because any situation that would cause the goal to fail will also cause the sensor to report a problem. Let's try changing that though. I'm going to open up my state constraint for my sensor, go to my tags, and I'm going to edit this expression. Let's change this to 5. Now I have a sensor that reports a off nominal condition for temperature greater than 5. Now I have a sensor that reports off nominal if the temperature is less than or equal to 5 or greater than or equal to 100, and a goal saying I need to keep my temperature between 10 and 100. Let's see what Frigate says. The Frigate says we have a failure. We hover over again. If the temperature is 6, our goal fails, but our sensor does not claim a problem. So Frigate has found a counterexample to our sensor coverage. Let's fix that, and then we'll move on to another more complicated example. We can do examples of multiple goals, not just one. Here I have 2 different goals combined with an OR. I have sensors on each one. I can analyze the combination of multiple goals, and that passes, or I can analyze each child goal individually. Here's an example where I have 2 goals. One of them has a sensor, one of them does not. Let's look at what Frigate says. So Frigate says we're fine on temperature, but our pressure goal is missing a sensor. So I'm going to add a sensor to this picture. I'm going to drop a sensor in from the palette. We're going to call this pressure sensor. Oops. I'm going to define a new sensor. Let's make it blue so it's easy to keep straight which things are sensors. Okay. Now I need to say what the state constraint is that this sensor is looking for. I'm going to open it up and go to my tags, go to my nominal system state constraint, create a value, and I'm going to select an existing constraint called pressure bounds. And just for readability, I'm going to add a dependency line between my sensor and the expression that defines the constraint that sensor looks for. So now that I've added this, let's rerun the analysis. It's still mad at me. Oh, I see. I forgot to allocate my sensor to my goal. So the one thing I have to do still is I have to add an allocation line from my goal to my sensor And let's see if it's happy now. Much better. You might notice we've been getting this zero redundancy message. What that means is if I delete any one sensor from this diagram, maybe I can delete this temperature sensor. If I delete any one sensor, we're going to fail. Yep, and there we go, we failed. Let's undo that change and see if we can increase our redundancy. It should be pretty easy to do that. We can do it in a really simple way by just adding more sensors. We'll add temperature sensor 2, and we'll put back a missing pressure sensor. And let's associate these with their goals. I'm going to assign a state constraint to my temperature sensor. And we'll set the colors for these to be consistent. Now let's rerun that analysis. So we used to have 0 redundancy, now we have 1 redundancy. That means we can delete any single one of these sensors and we will still have sufficient sensor coverage.